Students, welcome to the online lecture and tutorial. Today I'm going to deliver the lecture on electromagnetic spectrum and ultraviolet rays production mainly through sun alpine lamps. Yes, so we all know that we are surrounded by various electromagnetic rays, yes, throughout our day. Yes, we are communicating with our cell phones, we are using microphones, we are using microwaves, we are using our tablets, we are watching TV, we are seeing objects. Yes, all these waves. We are going for a X-ray. Yes, so all these waves comes under electromagnetic spectrum. Yes, now it is an interesting fact to be understood that what is electromagnetic spectrum? Yes, as the name suggests, electromagnetic spectrum. Electromagnetic spectrum. Yes. Now, this electromagnetic spectrum, if you divide the words, yes, electromagnetic, this means any wave or any radiation having the property of electrical plus magnetic properties, and spectrum itself says that it is an umbrella. Yes, yes. So this means an electromagnetic spectrum is a huge umbrella wherein various kinds of electromagnetic radiations are put under. Now, giving an example that we have a class of 70 students in first year BPT. Yes. Now, the roll calls are from 1 to 70. One number goes to A, two number goes to B, and so on. So, how we have divided the students? We have divided those students based on their alphabetical orders. Yes, similarly, in the electromagnetic spectrum, the waves are divided or placed according to their wavelength and frequency. इसका मतलब ये है कि अगर आपको एक एक्स रे चाहिए तो उसकी एक डेफिनेट वेवलेंथ है और एक उसकी डेफिनेट फ्रीक्वेंसी है, तो वही जगह पे आप जाओगे तभी आपको वो एक्स रे मिलेगा. तो इट इज सिंपल दैट वी आर लिसनिंग टू एफएम रेडियोस. हम हर रोज एक एफएम रेडियो सुनते हैं, तो 98.3 पे हमको रेडियो मिर्ची मिलता है, 104 पे हमको मिर्ची लव मिलता है, एंड सो ऑन. So this means a specific bandwidth and specific wavelength and frequency is been given to every wave or every atomic energy, every energy who is having electrical and magnetic properties. So please keep this in mind because this is a very important topic for first year BPT students. Okay, so moving ahead with our uh, lecture. Yes, so what we are going to discuss today is we are going to discuss about electromagnetic spectrum and UVR, ultraviolet radiations, which are the sun is the natural source of that ultraviolet radiations. Okay, so to be precise with the definition, yes, what is electromagnetic spectrum? The orderly distribution of electromagnetic radiations according to their wavelength and frequency is called electromagnetic spectrum. This is very important definition. Yes, if, as I said, if I have 70 students in the class, I have orderly distributed those students based on their names. Now that name starts from A to Z. So this means a person whose name is starting from A will have a roll numbers ahead from the person whose name is starting from Z. Yes, so this means the orderly distribution. I am distributing the waves as per their frequency and wavelength. I am highlighting this part. Clear? The electromagnetic spectrum is very much wider in the range, with the variation from 6 into 10 raised to minus 14 to 6 into 10 raised to 6 meters. Please make sure that you are aware about this, because this is one of the most important MCQ. So the electromagnetic spectrum has a much wider range, with the wavelength variation from 6 into 10 raised to minus 14 to 6 into 10 raised to 6 meters. Yes, and the credit goes to whom? The credit goes to Maxwell in 1865. Maxwell in 1865, yes, had predicted theoretically electromagnetic spectrum, and Hertz in 1888 confirmed it through experiment. So Maxwell was the person in 1865. He had predicted electromagnetic spectrum in theoretical basis, whereas Hertz in 1888 had proved the same through experiments. Yes. So now, making it very interesting, I would like to show you one video. Yes, based on electromagnetic spectrum.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless. Yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across the spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves, which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum.
So here, what the person is trying to say, yes, it is the foundation of the things which you are doing in current world. So even your radio, your remotes which are operating on infrareds, your cell phones, your X-ray, if the doctor is taking an X-ray, microwaves, visible light, TVs, all are part of electromagnetic spectrum. Okay.
Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy.
Yes. So what is electromagnetic spectrum? Yes. How does electromagnetic spectrum works? So what here he is trying to say, electromagnetic waves are similar to ocean waves, as both of them are energy waves. Yes. So both of them are energy waves. Clear?
EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But
yes.
Unlike
so, as I said, your EM waves, yes, electromagnetic waves will have electrical plus magnetic properties. frequencies. Clear about this?
Ocean waves that require water, EM waves travel through the vacuum of space.
The difference between your ocean waves and EM waves is that ocean waves require a medium travel and EM waves can travel in vacuum also. So this is the reason we can have visible light, we can have ultraviolet rays coming to the earth surface, though the natural source is sun. Clear?
At the constant speed of light. EM waves have crests and troughs
Yes.
like ocean waves. The distance between crests is the wavelength. While some EM
This
wavelengths
is your
are
wavelength.
very long and are measured
Crest to
in
crest
meters,
difference is wavelength and it is generally measured in meters.
nanometers. The number of these crests that pass a given point within
1
1
second
is described
is
as the
frequency.
of the wave. One wave or cycle per second is called a hertz.
Hertz. So frequency is measured in hertz.
Such as radio waves
So please
have the
see
lowest
this.
frequency and carry less energy. Adding energy increases the
So
frequency.
please see this, as you go from radio waves to gamma rays, the frequency will increase and wavelength will decrease. So your wavelength and frequency are inversely proportional to each other. So you can see this. See, gamma rays are having highest frequency and radio waves are having least frequency.
Not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station and microwaves.
See, we are surrounded by waves throughout our life.
Wi-Fi and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers.
So this is what he is trying to say, that we are having so many waves, then why we are not able, or why these waves are not combining with each other? Yes. So for example, if you are watching this lecture on your cell phone or on TV, yes, now why aren't you able to see UVR? Why aren't you able to see IRR? Or why you are not able to see gamma rays? Because our eyes are just adaptable. Our eyes can just recognize the waves which are in this visible light spectrum only. So that is why we are able to identify the colors and we are able to see only and only what visible light is.
Visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length
Yes.
are reflected, and our eye interprets this
as green color.
Green.
Clear?
Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared
Yes.
waves.
Yes, so this is what the video is trying to say. We are just able to see the green color because it comes under visible light spectrum. Apart from this, we cannot see infrared, we cannot see UVR, we cannot see gamma rays or X-rays, as our eye is not having that much capacity to visualize.
More about the world around us. Scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light.
Yes.
Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
So this is what our electromagnetic spectrum says. Yes. So now we are going to understand what are the sources, uses, dangers of electromagnetic spectrum. So this figure or this table states that low the frequency, longer the wavelength, high the frequency, shorter the wavelength. This means if the frequency is high, the crest to crest difference or the crest to crest distance is very near compared to long wavelength where crest to crest difference is more and it is low frequency. So we have radio waves, we have microwaves, we have infrared, we have visible light, ultraviolet, X-rays and gamma rays. Yes, so as we go on from radio waves which has low frequency, yes, then as we go on this way, the frequency increases. So the frequency is supposed to increase. So my easiest way, I always tell my students that how you are supposed to remember that how to remember electromagnetic spectrum. Yes, it is very simple. When do you listen to radio? Just keep it in mind, for electromagnetic spectrum, when you listen to radio when you are in low mood. This means when you are in low mood, you are listening to radio waves. This means radio waves are having low frequency. Yes, clear? Then where do you listen radios? Yes, generally you listen radio in kitchen. So where do we have kitchen? What do we have in kitchen? We have microwaves. Yes. So why do we use microwaves? To heat. So now every heating object emits infrared. Yes. Now we do have infrared. So red is the part of your visible spectrum, visible light. So this is your visible light. Now after we have one section infrared. So it is obvious after visible light we have ultraviolet. Yes, तो एक साइड विजिबल लाइट का इंफ्रारेड हो गया. Why? Because उसकी फ्रीक्वेंसी कम है. जिसकी फ्रीक्वेंसी विजिबल लाइट से ज्यादा है उसे बोलते हैं अल्ट्रावायलेट. Yes, and then U और V के बाद क्या आता है? What comes after U and V in ABCD? It comes X-rays. And then at the end, X-rays are in hospitals. Similarly, gamma rays are also in hospitals to treat the patients. So this is the very simplest way to understand or remember electromagnetic spectrum. I would again like to elaborate this for all of you so that you can easily understand, you can easily memorize electromagnetic spectrum. Yes, how do we memorize electromagnetic spectrum? Very simple. आप रेडियो कब सुनते हो? When you are in low mood. So means radio waves are low frequency. रेडियो कहाँ जनरली होता है? किचन में होता है. तो किचन में क्या होता है? माइक्रोवेव. माइक्रोवेव क्या करता है? हीट करने के लिए यूज करते हैं. तो वी हैव इंफ्रारेड. इंफ्रारेड एक पार्ट हो गया, तो दैट इट इज रेड, इट इज विजिबल लाइट. After visible light on one section, if it is infrared, on to the other section it is ultraviolet. So अगर अल्ट्रावायलेट है तो यू और वी के बाद एक्स आता है, तो इट इज एक्स रेज. एंड देन वी हैव गामा रेज. So this is how we have the electromagnetic spectrum. Rays, radio waves kahan se aata hai? It comes through electronic circuits. Microwaves also comes through electronic circuits. Infrared comes from warm objects, sun and electronic devices. Light comes from electronic devices. Hot objects, sun, obvious. Ultraviolet is also like sun, is the natural source. Gaseous discharges. X-rays comes through very fast electrons, and gamma rays through nu- nuclear metals. Yes, and typical use कहाँ कहाँ होते हैं? रेडियो कहाँ यूज होता है? कम्युनिकेशन सेट्स में यूज होता है. माइक्रोवेव्स कम्युनिकेशन सेट्स में यूज होता है. हीटिंग फूड, हीटिंग वाटर, हीटिंग सैटेलाइट्स में माइक्रोवेव्स होता है. इंफ्रारेड भी थेरापेटिक पर्पस यूज होता है. लाइटनिंग रिमोट कंट्रोल्स में यूज होता है. लाइट इज सीइंग फॉर फोटोग्राफी. अल्ट्रावायलेट ट्रीटमेंट पर्पसेस, विटामिन डी सिंथेसिस. X-rays also capturing images, defects in bones, hidden devices, and gamma rays for cancer. So radio waves are generally safe, very safe. Microwave थोड़ा सा burn करता है as it gives heating. Infrared also burns. Yes, लाइट ऑब्वियस बीइंग बर्न करता है. एक ज्यादा लाइट देख लो तो आप ब्लाइंड हो सकते हो. कंसंट्रेटेड अल्ट्रावायलेट इज आल्सो हैविंग स्किन इफेक्ट्स, सनबर्न्स एंड स्किन कैंसर. X-rays are having cell destructions, and similarly your gamma rays. So it is very simple, my dear students. It is very simple that you know all these things are in your day-to-day life. So this becomes your electromagnetic spectrum. Clear? Now, as we all know, what is ultraviolet? Ultraviolet radiations fall. Where do ultraviolet radiations fall? Ultraviolet radiations are falling above, beyond the visible light. So that is having 10 raised to minus 7 to 10 raised to 8 minus 8 as their frequent wavelength. Yes, so you can see the crest to crest difference of visible light is more compared to crest to crest difference of ultraviolet. So ultraviolet will be having more frequency, 10 raised to 16 to 17 compared to 10 raised to 15 to 16 of your visible light. Clear? So it is the region which is from the violet end of visible light till the X-ray region. Clear? Generally, as I said, we can only see visible light, so ultraviolet radiations are invisible to our eyes. Natural source is sun, and it generally produces chemical changes. Okay, where do they occur? Where are these radiations going to affect in our human body? Onto the subcutaneous tissue, hair follicles, and sebaceous glands. So they will generally have effect on skin. Clear? So this is where ultraviolet radiations will have their effects. Clear? क्या क्या करता है? Erythema, sunburn, tanning, increases the epidermal thickness, premature aging कर सकता है, skin carcinoma कर सकता है. You would have seen people complaining about prolonged exposure to the skin. Yes, and then prolonged exposure of UVA to skin and following into skin carcinoma. Very common in white population because they don't have that much of melanin component. Okay, exposure to the eye causes photokeratisis, and obvious being ultraviolet is helpful in synthesis of vitamin D. Yes, okay. So it has a common phenomena. It works on reflection, refraction, absorption, and penetration. So when the lights are incident ray is okay, this is your reflection, this is your refraction, okay, this is your absorption into the surface and penetration till the depth of the treating surface. So these are your reflection, refraction, absorption, and penetration. It is basics 12 science physics wherein all these radiations work here. Yes. So we all know that UVR are between the violet end of visible light till the X-rays. Now this UVR are basically divided into three portions. Yes, UVA, UVB, and UVC. Okay, so the highest long UV, yes, is 400 to 315 nanometers. 400 से लेकर 315 नैनोमीटर तक होता है. As it is the longest UV, it goes till the deeper layer of the skin, that is your dermis. Clear? Second is medium UV, 400 300 and 400 से लेकर 315 nanometers का आपका long UV. Medium UV, which is your UVB, yes, it is 315 to 280 nanometers. It is again responsible for inducing thin carcinoma, and it causes increases melanin component and vitamin D synthesis. UVC is the shortest UV. Okay, it doesn't reaches the earth's surface. Please see this, and it is 280 to 100 nanometers. 280 to 100 nanometers. Clear about it? So UVA है 400 से लेकर 315 nanometers का, which is long UV, which penetrates deep into the dermis. UVB is a medium UV, which is 315 to 280 nanometers, and UVC is 280 to 100 nanometers. Clear about this? So we would be moving. So as we all know, you know, uh, outer space we have on Earth, we have troposphere, stratosphere, meso and ionosphere, and the outer space. So you see this is UVC. It is not reaching to the Earth's surface. UVB is reaching bit to the Earth's surface. It is not fully reaching, but UVA, it is reaching deep to the Earth's surface. Yes, so UVA is 315 to 400 nanometers, UVB is 280 to 315 nanometers, and UVC is your shortest UV. Please make sure, very important MCQ question and short question about this. So generally, therapeutically, we can produce UVR. We cannot use just sunlight as our therapeutic modality. We have to produce UVR therapeutically. Now, this therapeutic production is done by high pressure mercury vapor lamps, which are also known as sun alpine lamps. Clear? Then we have chromium lamps and fluorescent tubes. Clear? So it is very much essential that you all know these kinds of productions. Now, making it very simple for all the students, yes, I will share you on whiteboard that what we were discussing about sun alpine lamps, also known as high pressure mercury vapor lamps. Yes, also known as sun alpine lamps. Clear? So these sun alpine lamps are nothing but a U-shaped A U-shaped tube. Yes, these sun alpine lamps are nothing but a U-shaped tube. Yes, this is bit okay, which is made up of quartz. So this U-shaped tube, this U-shaped tube is made up of. I'm having bit problem with drawing the diagram on. Yes. Okay. So this is a U-shaped tube made up of quartz. Clear? On onto the both the sides. Onto the both the sides of this U-shaped tubes we have electrodes. So I will be drawing this electrodes, both the electrodes on different colors. Yes. You can see this pink color. Yes, this is your positive electrode. I'll label it later on. And this is your green color electrode, which is your negative. Okay, so this electrode is given, is connected with the AC main supply. This both the electrodes are connected with each other with AC main supply, and 400 watts of current is given. In this electrodes we have, so with this, whatever which I am drawing with red color, this red color is nothing but argon. Okay, argon gas is there. Okay, and my blue color is my mercury. Okay, so now I will label this diagram. Yes, so positive electrode, U-shaped quartz tube, argon gas under low pressure. This is mercury. This one is negative electrode. And yes, this one is my AC main supply, 400 watts. Okay, so this is nothing but your high pressure mercury vapor lamp, as the heading says. Yes, so now what will happen? The high pressure mercury vapor lamp, it consists of a U-shaped tube which is drawn over here, filled with argon gas at low pressure. A small amount of mercury, which is shown in blue color. The pinkish reddish color is your argon gas under low pressure. The blue color is your mercury, is enclosed in the tube, and the tube is sealed by both the ends. You can see this tube is sealed by both the ends. Yes, a U-shaped glass tube is used to act as a point source. The burner, this U-shaped tube, also known as burner, is made up of quartz. And why it is made up of quartz? It is made up of quartz as the material allows the passage of ultraviolet rays and can withstand the high pressure. So for what reasons we are using quartz? On to left I will write why we are using quartz. Why we are using quartz. We are using quartz because answer is quartz can handle quartz can handle high temperature with low coefficient of expansion. Yes. So that is the reason we are using quartz. Yes. So please make sure you are understanding this phenomenon. It is very important Viva question also. Okay, at the ends of glass tubes, electrodes are placed which are having a potential difference. So generally a 400 watts of potential difference is given through a step-up transformer. Now once, why we are using this 400? We are using this 400 watts to ionize the argon. So this means, what is ionization? इसका मतलब ये है, now I will be using a different color, yellow color. ओके सो येलो कलर जब हम करंट देंगे तो पॉजिटिव आयंस इन येलो कलर will move towards this yellow color will move towards your negative electrodes, which are your electrons, and this electrons will move towards this. I will show it in a light greenish color. These electrons will move towards positive. So you can see these two, when these are moving towards, electrons and ions are moving towards both the other ends. You can see this, they are interacting with argon and they are interacting with mercury. So what will happen? Two phenomena will happen. Argon ionization and mercury ionization will take place. Clear about this? So this, once the argon gas has been ionized, the normal main voltage between the electron causes the positive and negative particles burning through the burner, constituting the electrical current. The electrons move towards the positive terminals and positive ions move towards the negative terminal. Collision between the ions and neutral argon causes further ionization. So this procedure will cause moving neutral ion. This procedure will cause flow of discharge, which is known as UVR. Also sufficient heat is produced to vaporize. This will produce heat, so thus mercury will vaporize. So this is known as mercury vaporization. So these three phenomena are very important. I will put it in red color. So argon ionization, mercury ionization, and mercury vaporization, these are responsible for production of UVR. Yes, sufficient heat is produced to vaporize inside mercury inside the burner, which takes about 5 minutes to reach its peaks. So when the lamp is turned off, ions of argon and mercury will recombine so that the tube everything in reports to the normal state. Clear with this? So I would like to uh, erase certain position why we are using quartz. I will erase this. Okay. Now we all know this glow off through this process will have a glow of color, which is this color. This is nothing but your UVR. Clear about it? ये जो ग्लो है जो मैंने ऑरेंज एरो से दिखाया है वो आपका UVR है. तो ये जो UVR है वो क्वार्ट्ज के साथ इंटरेक्ट करता है. this quartz, yes. So ये UVR आपके क्वार्ट्ज के साथ interact करता है, which becomes, so I'm showing gray color on both the sides. This gray color is nothing but, this gray color is nothing but tridamite. Now what this tridamite says, this is a silica. This is a silica like coating. Yes, some of the quartz changes to another form of silica. Yes, which is opaque. यस, तो धीरे 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 जैसे जैसे यूवीआर बनता जाएगा, वैसे वैसे वो क्वार्ट्ज के साथ रिएक्ट करता जाएगा एंड इट विल प्रोड्यूस सिलिका विच इज ओपेक. तो कब हमको इसको रिप्लेस करना पड़ेगा? आफ्टर 1000 hours of use. So the tridamite formation, certain amount of quartz changes to another form of silica called as tridamite because of very high temperature in the burner. It is harmful to the total output of ultraviolet as it is opaque. Yes, and thus with subsequent, जैसे जैसे आप UVR यूज करते जाओगे वैसे वैसे सिलिका का लेयर बढ़ता जाएगा and that layer will increase the opacity, and that is why we are supposed to replace the burner by 1000 hours of use. So इसके साथ हमको UVR तो मिलता ही है. Yes, we are getting UVR plus we are getting IRR because it is heating. We are also getting visible light. Clear? So high pressure mercury vapor lamps में आपको क्या क्या मिलता है? UVR, IRR plus visible light. So this is what we are getting. Now we will go to our PPT to understand the UVR. Yes. Yes. So this is your sun alpine lamps. जो मैंने आपको सिंपल ड्रॉ में दिखाया वैसे ही ड्रॉ करके दिखाया वैसे ही ये आपका sun alpine lamp है. See, this is a U-shaped tube. Clear? Quartz tube is mentioned. Tungsten filaments, electrodes are there. Okay. So as we all know, you know, the therapeutic UVR, the therapeutic UVR are produced by mercury vapor lamp, which consist of quartz burner tube and having argon gas and mercury under pressure. Now the question comes, if this is under pressure, why do we call it high pressure mercury vapor lamp? Because we call them high pressure mercury vapor lamp because after argon ionization, mercury ionization and mercury vaporization, the temperature and the pressure inside the burner increases. That is the reason why we call high pressure mercury vapor lamp. An electrode is inserted at each end of the burner. The current is applied through these electrodes, the mercury vapor passage, and the UVR is generated. Now in sun alpine lamps, it emits ultraviolet, infrareds, and visible light, which I've already mentioned. Clear? Falls within UVB range, mainly used for erythema purposes. The heat produced inside the burner or quartz tube causes some amount of it to change. That is known as tridamide. So this is very, very important. Your tridamide, which is opaque and the output reduces. A variable resistance is generally included in the burner circuit to increase the potential difference across the burner and increase the intensity of the current. So why do we use resistance? क्योंकि जैसे जैसे ट्राइडामाइड बढ़ता जाएगा वैसे वैसे आउटपुट कम होता जाएगा, तो जनरली उसको ओवरकम करने के लिए we use variable resistance. Clear? The photochemical, yes, of UVR is 250 nanometers. Clear about this? So this is what your UVR says. So with this, what are the points we are taking through this lecture? What we have learned? Points, important points from this lecture. First point, define electromagnetic spectrum. Second point, orderly distribution of electromagnetic spectrum with its uses and dangers. Third point, classification of ultraviolet rays. Fourth point, production of mercury, high pressure mercury vapor lamp, that is your sun alpine lamp. So these are of this, and in this what we have taken important points: argon ionization, mercury ionization, mercury vaporization, and tridymite formations. So these are the important points through this lecture. I would highlight it in red color so every individual learns this. So please make sure that you are aware about this. Yes, and let us end this lecture with a very smileful face. Yes, I'm very much bad at drawing. Yes. Okay. So thank you very much. Thank you for listening to me. Thank you, my dear students. Thank you, dear students. If you have any doubts, please ask me, and I'm ready to solve you at any point of any doubts. I will solve at any point of time. Thank you. Thank you very much.